Hi, I'm Larry McIntosh. I'm a principal engineer that works for Sun Microsystems, and I'm here today with you to speak to you about an architecture that we put together encompassing our Sunfire 4170 systems. Also inclusive of that is some very nice flash technology to show how we can give great performance boost and accelerate applications as well as accelerate Oracle database on the back-end side. On the diagram up here, what we have are 5 systems. We have a Simulation Manager portal. That's a portal that uses a web interface that will be discussed a little bit later by a colleague of mine. And then on the 4 systems that are underneath this, we have 2 systems that are computational node systems that run the Nastran application. Nastran's used worldwide for structural analysis for things like the automobile industry when they produce their products, as well as the airline industry. Also, in conjunction to that, we have 2 systems that are running the Oracle database environment on the back-end side. And what's significant about this is we're doing an analysis and comparison of the use of hard disk drives on one of these systems that are computational node in comparison with the flash devices that are placed in the same kind of configured system on the computational node, and also the same thing we've done on the Oracle database. So basically the bottom line is we've taken 4 disk drives that are hard disk drives out of 2 of these systems and replaced them with 4 solid state devices. Now, what you see here in the rack is the corresponding live running systems, all 5 of them that are actually actively engaged with this architecture. But more importantly, if you look over here, you'll see that these 5 systems are actively running a demonstration at this point in time. 2 of these systems we have actively engaged with the Nastran application. What's important about this is that this particular system is the hard disk drive system for Nastran on the computational side, and this was the one that actually has the flash architecture that's been placed in it on that same configured type system that's also running Nastran. There's 8 concurrent jobs that are running in conjunction with each one of these systems. So we launched this application, this 8 continuous job run, on both of these systems at the same time. The activity is very dynamic here. This particular point of the screen is showing load activity, and this is actually showing disk drive activity. So we're live running now. And what we've done is we've actually charted this activity, and we've seen that from our data that we got, the length and time for the Nastran runs, that on the hard disk drive systems, we'll run those 8 concurrent applications for well over an hour. What's nice about the use of flash is that flash will give you over a 58% performance improvement, and more importantly than that, you'll actually get that same amount of job activity run concurrently in less than half the time. What does that mean from a productivity standpoint? It actually means that you'll get more than twice the amount of production jobs run on a single system than what you would actually be able to do on 2 systems if you employ the use of flash architecture on the single system. Now, what I'd also like to do is also hand this over to a colleague of mine, Dale Layfield, to be able to talk about Nastran as well as Sim Manager in more detail.
Hi, my name is Dale Layfield, and I'm in the ISV engineering organization, and I do a lot of support with the MSC Software Corporation and their structural analysis program and their simulation management program. And as Larry was saying, some of the key features of the Nastran program is that it's very I/O and CPU intensive. And so what we found, as Larry was talking about, is that not only with the new Intel 5500 series processors, you get a great reduction in the processing, the elapsed time for doing the processing. You also get a great boost when you add in the solid-state devices. And as Larry was saying, you can actually cut the time in half on a structural analysis program. And in addition to that, there is a parallel tool that MSC Software develops that actually keeps track of all these Nastran jobs, and that's called Sim Manager. And it's a simulation management tool that keeps track of the sometimes hundreds of thousands of simulation runs that an engineer may make that he tries to store and retrieve at a later date to perhaps revise and resubmit and redo the analysis. And we can come over to this window here and actually show you that particular interface. And that interface is shown here as the MSC Sim Manager product. And what you're seeing here is basically Nastran analysis runs that were made prior to this, this event. And basically what this tool is good at is keeping track of every simulation run that an engineering organization makes, and then at a later date you can go back to it and pull it up. And what we're doing here is demonstrating when you have these millions of objects, hundreds of thousands of simulations, what the Oracle database is doing is storing all these. And what we're demonstrating in this demo here is actually the performance gains that are obtained when the Oracle database resides on a solid state device versus the Oracle database when it resides on an HDD device. And basically what we have found during our test is you can get a 6x speed up, which is a tremendous speed up by storing the simulation data on a solid state device Oracle database versus a HDD resonant Oracle database.